Hey everyone, if you're new here, my name is Joe Blackler. I am a principal engineer based here in London, UK. Today I want to talk you through an app that I've built over the past year called OneHaus and its high-level architecture and some of the choices that I decided to make for it. So the reason why I built this app in the first place was two reasons. One, I basically kept getting to-do lists on WhatsApp and we kept getting lost in the conversation and things. So I just needed a way to track it. And two, I needed a way to experiment with AI. And what better way to do that than with an actual project? So I went into this with an idea of let's just build something for the house, something that me and my wife can use, and hopefully it's useful for other people as well. So what we're going to do today is just take you through the high-level architecture of that, like I said. But I think it's important first to go through some of the features that the app has and explain some of the context and stuff behind the scenes. So initially, this app just had a couple of features on it. So it just had the tasks, the events, the shopping list. Over time, expanded that out to include documents, subscriptions, and all that kind of stuff. And they all inherit from the same kind of entity we'll go through later on. The idea was that we would be able to chat to our house using a chatbot. As you can see at the bottom of the screen here, we've got this ask me anything about your house. We could just ask it any questions about all the data that we had inside of it. If you're interested, the app is free to use, but that's not the purpose of this. The purpose of this is to take you through this high-level architecture and explain some of the stuff that we have up and running. So for the majority of the application is currently hosted on AWS with Lambda, DynamoDB, a classic kind of serverless architecture, nothing too special or fancy in that regard. The website is currently hosted on Vercel as well. And it just talks to the API to do some authentication related things. Otherwise, it's completely isolated. So why am I kind of showing you this part first? And I think the reason mainly is because it's not how I would design it if I was going to build it as a serious commercial product today. There's a lot of learnings and stuff that I've got throughout this process that I think are important to share. The first one of those actually is how we do these lambdas first. So initially, I just had an API and it just had a single chat endpoint on it. I wanted to keep it very, very minimal and then just make every single operation happen through chat. And whilst it worked, and it definitely did the job, as you can imagine, the API costs for running on top of AWS Bedrock with like a Claude model sitting in the background, that got quite expensive just in testing, let alone real usage. So a lot of the stuff that I actually did, I started moving over to REST endpoints, pretty standard, and then just fed it in a different way. And I'll explain how the internal chat and the MCP work under the hood in a bit as well. So yeah, the API started off as one endpoint and then expanded out to cover the REST endpoints, which made the mobile app a lot faster, a lot more lightweight, and a lot easier for the development experience. The Lambdas are hosted with ECR, so the container-based .NET AOT, but that does lead me to another problem that I had during this architecture. One of the reasons why I would probably change it, and that's the kind of cold start with Lambda and ECR in general. We've tried this a few times in a few different ways through various companies and things. And one thing that we've always found is that for whatever reason, AWS is pretty slow at pulling an ECR image and then starting it up for the first time. It can take a couple of seconds sometimes, and that really severely impacts the performance of the mobile app, especially when there's low usage involved. So the easiest workaround that I found for this one is I just put on provision concurrency, just set it to 1 and accepted the API cost. I did that the same thing for the MCP server because I thought people would be using the chat instance and it would be really, really good. But over the last couple of days, I've actually taken it off because the adoption on the MCP side of things isn't as broad as what I was necessarily anticipating it could be. So it's just a bit of a cost money optimization there. And arguably it's not as important either because these guys over here are expecting latency from the MCP tools that they call. So it's quite straightforward to take it off and save a bit of money on that regard. Then on the background side of things, we've got DynamoDB in pay-per-request mode, so no usage, no cost. And then we've got a change stream processor, which goes out to everything like my Discord webhooks, for example. So I get notified anytime someone signs up, deletes an account, payments, all that kind of stuff all goes in through to a dedicated Discord channel that I've got. And then we've got an implementation of the action runner pattern that I referenced in my previous video. And this is basically just an SQS FIFO queue with deduplication and stuff on it, and a way to constrain any kind of usage that goes like beyond what I would want to pay for. So we don't want to get up to like thousands of request units and stuff like that when we can make it a little bit slower and not congest the change stream processor. So I've implemented that pattern that I've done in the previous video. And then we've got some timed operations with EventBridge as well. So that covers most of the kind of like the back end. EventBridge just has a few different things on schedule, such as daily notifications. So everybody in each time zone has a different notification schedule, and it's a little bit adapted depending on that time zone. So we trigger something every hour, pushes it into the queue. Queue then processes stuff according to the database, and of course then changes come back up, which might enforce other changes. An example of that is actually an AI review as well that we run every single week. It starts off as an event bridge, gets triggered once a week, comes down into here, writes into there, and then we process some changes and then notify people as well. On the mobile side of things, it's actually quite interesting. I used Flutter for the first time on it, and that's generally been a good experience. Claude has definitely had some issues with it. I've had to make a few adjustments to Claude.md files and bits and pieces to get rid of some problems that happened with a provider called Riverpod, and they basically hold some state on the mobile side of things, and Claude kept getting confused about it, but I think we've eventually got the right pattern on that now. And the way it works on the mobile side of things is it always expects the internet and you to be connected. And then every time you do an operation, it goes from the mobile app over to the API and then says basically, hey, I've done this operation. And then once the API responds with hopefully a success, then the mobile app goes, okay, things have changed. Let me go and resync all the changes. And then most of the kind of lookups and stuff are handled on the mobile, which gives it this really nice, snappy performance that, yeah, you can kind of use. The only other bit of this architecture that's not currently in here, if I forgot to draw beforehand, is how I actually talk to the AI models themselves. And to do that, I use AWS Bedrock. It is actually not something I would recommend going forward. It has some benefits, and the reason why I picked it to start off with is because it was integrated with my AWS bill, and I could see everything in one place to kind of see, what the costs, what's the breakdown of the costs. But in reality, I actually had quite a few problems testing out different models and stuff like that. And the latency can be quite bad at times as well, which negatively impacts performance. So that's something in the future system that I will actually take out as well. So I can't remember where I was going with that now, to be honest. Yeah, so what I would actually change that to in the future is Open Router. I've been using it on my latest project, Verify MCP, and that's been a lot easier to kind of use and set up. And I can access a lot of other cheaper models like DeepSeek and stuff as well. The other thing about AWS Bedrock as well is it tries to provide its own unique unified service layer. So it says, oh, this thing is supported, and then you go to use it and then actually figure out at runtime, actually no, that thing is not supported despite it being exposed on the API surface and stuff like that. So it's kind of one of those classic patterns where like the API surface says, here's everything you can use, and then you need to go and read all the documentation to go and figure out actually, is that thing actually useful or not, or that kind of stuff. So overall, that's kind of the high level architecture. We've got some rules get triggered on Event Bridge. We've got AWS Bedrock, and then we've got our two main ingestion points with the API and the MCP. So what I want to go through as well is how did I do the MCP server and a dedicated chat endpoint on the API. So we'll just scroll down and we'll just take a look at that. So on the MCP Lambda, we're using the official SDK, which is now version 2, I believe. It supports the latest 2026 standard of MCP, which makes it a lot easier to run stateless stuff on serverless, which is really, really cool. So these are two individual projects, MCP and API. And then they share an, I think it's called house.ai.core. And inside of that core package is basically all of the tools and different bits and pieces, all the request response models and stuff that is needed for it. Then on the API side, it has a couple of additional little components. It's got the, let's call it the agent loop. And this is the thing that we start off the chat to, and it goes around and says like, here's the system prompt, here's the assistant, like the user message, and then it gets a reply, and then you might have some more and stuff like that. And then that is all tracked as well through like a conversation. So we've got like a DynamoDB conversation API that's referenced inside of core. So it doesn't matter kind of what kind of goes on. We track all the conversations inside of there. So this guy manages his own agent loop, and then there is an adapter for tools, which then reads the tools from that central directory. And it converts it into the AWS Bedrock format and feeds it into that tool loop. And it's literally just a case of the AI will say, invoke this tool, and then the tool adapter will locate that tool and invoke it with the right parameters and stuff like that. Similarly, on the MCP side, there is a tool adapter as well, and it does pretty much the same job, just formatting the tools that we've got in the AI core through to the MCP kind of format, because they do actually differ in slightly different ways, which makes it really, really fun to try and manage. Hence, we got this AI core kind of project that contains all of the logic and the data. So if I do add a new bit of functionality, it's exposed directly on the MCP and on the API as well. And then everything is tracked, like I said, through the conversation API, and that comes complete with TTL, so all the conversations are cleaned up and such like that as well. What this means is then I'll get this really nice debugging experience as well. So if someone comes through to me and says, hey, it did this really weird thing, I can go back and look at the conversation history and say, oh, okay, that's a really weird scenario of what happened here. Was it just the AI model being a bit silly, which, spoiler alert, it does? Or, is it something that I've done wrong, etc. One of the issues that I did have with, I'm not sure if it's the model itself or if it's AWS Bedrock, but it does sometimes have like all these wrappers around it. So sometimes I want a JSON output, for example, and it gives me that JSON output, but surrounded in Markdown tags, or it'll give me an XML sometimes, which is really not very handy when you want a JSON API kind of coming out the back of it, so you can deserialize it to a set model. And for context, that model comes back something like this. So we have an object, we may like have a message to the user, which would be like, hey, I've done this thing. And then we get a series of entities that come out the back of it as well. And these are just key pairs of what entities and stuff get pulled back. So it will have a type field, and it might say like shopping list item. And then it'll have an ID of 1, 2, 3. And on that, once we get this result back, we pull back the entities from DynamoDB as well. And then we get this nice, real good experience for the user where they get the message back from the agent, and then they get little cards that they can go and click on to say, like go and edit this thing or go and view this entity right now. And yeah, the reason why I did that is I wanted to save a little bit on the output tokens, and I didn't want the AI to kind of try and emit all that information because, again, it was getting it wrong. So yeah, in terms of handling the payments and stuff, that's all handled by something called Revenue Cat. So I'll go back up to our design up here. And basically what Revenue Cat does is it talks to the stores like the iOS App Store, the Google Play Store, and then it just sends me through webhooks to say when things have happened, and then it provides me a nice little UI on top of that for knowing how many customers and stuff like that I've got. For the website, analytics-wise, I use something called DataFast. So DataFast is written by a guy called Mark Liu, really, really nice, Google Analytics alternative, and also puts the revenue directly in line with the website visitors and stuff like that. And then on the mobile side, I use PostHog. So we can see do things like screen recordings, and if needed, to debug sessions. We get analytics about what devices people are using, in addition to what the stores give me, and all that kind of stuff. So earlier on, I did say that this is not necessarily the architecture that I would go for today. So I'm going to go and take you through what I would do today. So today I would keep the mobile app in Flutter. That side of things is not changing. And the analytics side of things, it wouldn't be changing. So PostHog, Revenue Cat, DataFast, that would all stay the same. But what I would do today is I would actually host this on a VPS instead. So kind of using something like Hetzner or Hostinger. And then I would run the individual services in here. So I would have a Docker container for the API, Docker container for the MCP, and then kind of a scheduler worker type container. And that would be talking to a Postgres database. Whilst there is a lot of kind of useful parts about the architecture that I've currently got in terms of serverless, I find that I could probably provide a better experience overall with things like the API, because what I can do is, instead of manually writing the syncing code and stuff like that, I can do a kind of a SQLite to Postgres kind of proxy between the two and make that a little bit nicer. Everything becomes a little bit more stateless. We can run maybe something like an actor-based system instead and experiment with those kind of ideas. And then out the back, like I said earlier, we would have OpenRouter for the model access, and then we can go through and talk to that. I'm just going to go down there. You can kind of get the idea. Crucially, I would also put the website in here as well. And then the other change I would probably make today is if that's my VPS, then I would put Cloudflare here. And then completely close off access to the different APIs and things. So I'm just going to take those, move those to the right. And then I would have Cloudflare tunnel here, which if you're not familiar with it, basically you can take the tunnel. It's a Docker container you can use, or just kind of a standard executable. And then it talks out to Cloudflare's network and provides a proxy back in to your application. So you get all the benefits of the firewall and stuff like that. And it means you can completely close off the outside edge to your VPS or wherever you're running your origin servers. And then what request goes into Cloudflare, it drops down on the Cloudflare tunnel, and then it proxies it back inside for you. So yeah, and then the other thing to manage access, because obviously you don't want SSH in here, the other thing I would have in here would be Tailscale. Really, really cool project. It works in a similar way to Cloudflare Tunnel in the sense that that daemon spawns out a TCP connection to either Cloudflare or Tailscale's services, and then they proxy the traffic over that tunnel back to us. So it's a reverse proxy in that, or reverse tunnel in that sense. So yeah. In terms of costs, it really depends on how cheaply you can get those servers. So I think I've seen them for like £15 a month, which would comfortably run this architecture at the scale I've got currently, versus what I've got over here, which is more like $50 a month on AWS. And that the primary cost drivers are AWS Bedrock, which is currently using the Claude Sonnet model for most of my things, and the provision concurrency on the API and EMCP. So redoing this again, I could probably save $15-20 and run it here. And on OpenRouter, I get to pick between the different models and switch them out really, really easily without worrying about API surface and stuff like that, because OpenRouter handles the unified surface for you. And I could probably run the latest GPT 5.6 Luna or something like that. So yeah, that is pretty much all I've got time for today in terms of talking you through the high-level architecture. If there's anything that you kind of want to know or anything like that about the architecture, then drop a comment below and I can probably do a follow-up video or answer your questions directly, depending on what it is. And yeah, I'll do another breakdown of how I did a Verify MCP, which is my latest project, which is done in this architecture. And I can go through some really interesting problems in there in the next video. But otherwise, take care, and I'll see you soon.